ferromagnesium silicates. There are two different types of silicates, ferromagnesian and non-ferromagnesian. So we're going to start with the ferromagnesian. So in fact, ferromagnesium, ferro meaning iron. So these contain both iron and magnesium. So put iron. I'm going to abbreviate iron as Fe, so if you don't know that abbreviation, I recommend learning. Magnesium is Mg. So these contain both iron and magnesium. The fact that they have iron and magnesium influences their physical properties. For example, because they have iron and magnesium, they tend to be dark. Dark, when you're talking about minerals, includes black, green, red, all things that are dark, brown, things like that. So they tend to be dark. They also tend to be dense. And they have an average or a density range from 2.7 to 3.6 grams per centimeter cubed. With an average density of 2.9. They dominate the oceanic crust because oceanic crust is made of basalt, which is pretty much all iron and magnesium silicates. Ferromagnesium silicates are divided into several groups. First group we're going to talk about is the olivine group. So here's a picture of the mineral olivine. Olivine are isolated tetrahedra. So with the different types of silicates I talked about in the previous lecture, this is isolated tetrahedra. And the isolated tetrahedra are linked to iron and magnesium. So it has a lot of iron and magnesium in it relative to some of the other silicates in this group. So the example I gave you is olivine. Olivine is also a precious gemstone called peridotite or peridote. It has this olive green color as its diagnostic characteristic. So that's where it gets its name from. It can be granular. You can see like here, these look like little crystals, but it's very granular. It looks like grains of sand. Okay. The next group is the garnet group. Which is made up of garnets. These are also isolated tetrahedra. So the isolated tetrahedra are very low in silica and oxygen and abundant in a whole bunch of other stuff. So olivine group and garnet groups are very low in silicon and oxygen. And so the isolated tetrahedra, they bond with several other things. Garnet group has a wide variety of different garnets. You can see they come in a wide variety of colors, but they form something called dodecahedron in their crystal form. Dodecahedron are dodeca, meaning 12, hedron, meaning shape, so it's a 12-sided shape. So here is two that are looking perfect crystal form. They make like these diamond patterns and they connect, and they make a 12-sided shape. So these are dodecahedrons. Garnets are mainly found in metamorphic rocks. So they're a metamorphic mineral, which we'll talk about once again when we get to metamorphic rocks. The next group is pyroxene. Pyroxenes have calcium, magnesium, and iron, so you're adding calcium into mix. They have a little bit more silicon and oxygen than isolated tetrahedron because these are single chain silicates. So they have a little bit more silicon and oxygen. They can be green, brown, black, just depending on the member of the group. Because they're single chains, and the chains basically are the strongest point because the silicon and oxygen are covalently bonded, and then they ionically bond with everything else, you get two cleavage planes at almost 90 degrees. So all pyroxenes have two cleavage planes almost at 90 degrees. And in this one here, you can see this is almost 90 degrees. Here's the first surface, here's the second surface. That's the 90 degrees, and that's the two cleavage planes. This one, you can see this is one surface. It's hard to see it, but you can see how it's making like these steps. Those are the two cleavage planes. Many pyroxenes are found in mantle rocks. I'm sorry if you can hear my cat. She's old, she's 17, she likes to be very vocal. So this is the pyroxene group. The pyroxene group looks very similar to the next group, which is the amphibole group. There's some differences, but they look very similar. They contain aluminum along with calcium, magnesium, and iron. So if you don't remember these abbreviations or don't know these abbreviations, you should write them down. Al is aluminum, Ca is calcium, Mg is magnesium, and Fe is iron. So they're containing aluminum. They're also a double chain silicate. So this will change their cleavage planes because now you have two chains bonded together that are ionically bonding with other things. You still have two planes of cleavage, but at 60 and 120 degrees. So that's the easiest way to tell these apart because a lot of them have similar hardnesses, they're similar colors, they're blacks, browns, and greens, but they have cleavage at 60 and 20 degrees versus 90 degrees, which is really hard to see in these pictures. Hornblende is the most common example in this group. And hornblende is right down here. This is hornblende right here. Hornblende usually looks like it has these little needles. Hornblende looks very similar. These needles are actually the 120 and 60 degree cleavage planes. So this is what it generally looks like. And it makes these needle shapes. Generally it's black, dark gray, because it has the iron and magnesium. But this also has a little bit more silica in it than the amphibole group because it's a double chain versus a single chain. And there's one more ferromagnesian group, the mica group, which this has actually minerals in both ferromagnesium and non-ferromagnesium, but we'll talk about the ferromagnesium ones first. Mica group are sheet silicates. So you have sheets of silicate tetrahedrons, covalently bonded, and then the sheets are ionically bonded to cations. So these have one plane of cleavage. That is an excellent plane of cleavage. They're called sheet silicates. Like if you look at the biotite, you can see it's folding up. These break in sheets very, very easily. You can see like they look layered. And that's basically the ionic bonds between the sheets of the covalently bonded silicate tetrahedrons. And so biotite is the most common ferromagnesian of this group.